Thank you, Daniel. And Pete, I'm very happy to have you here for the conversation. You've worked as an application developer at both Facebook and Twitter, as well as in engineering management. So I'm very happy that you could join us today to shed some light on the application data infrastructure that enable developers at these tech companies to move faster than the industry average.
Yeah, of course. I'm super happy to be here. Thanks for having me.
Let's start right in, and I'll start with some introductory questions. So, as you know, Prisma Client is an ORM, and we believe it's one of the best ORMs available. And we're receiving a lot of praise for how it is to use for database queries and the fact that it is fully type safe. It is being adopted by individual developers, startups, and teams of all sizes and enterprises. But as you know from your experience at Facebook and Twitter, at a certain scale, a normal ORM is starting to limit the productivity of your development teams. So maybe you can talk to that a little bit.
Yeah, I can definitely speak to that. And I would say that I think calling Prisma an ORM is maybe selling it a bit short. Like normally, I don't really like ORMs, and I wouldn't really say that a lot of my complaints that I have about most ORMs are present in Prisma. I think Prisma kind of sits at a bit of a higher level. So maybe I'll talk a bit about just data access generally, and how that maybe ties into ORMs, and how perhaps Prisma is redefining the term ORM to being like this higher level abstraction. I don't want to speak to your vision or whatever, but that's just kind of my interpretation of it. So broadly, the way that first the challenge that a lot of these large internet scale companies have, and it's really a function of both the scale of the production traffic, but also the scale of the engineering team. And in fact, I think the scale of the engineering team is the more interesting problem to talk about. So as you add more engineers to your team, you need to figure out, how do I get these people productive without them stepping on each other's toes and without them creating a bunch of security incidents? That's kind of, I think, one of the main things that engineering leaders get concerned about is we want to get them productive as quickly as possible. We don't want them to slow down our velocity as we bring on more people. We don't want to introduce risk effectively. And so when I joined Facebook a long time ago, and we were just in the midst of rolling out what you would maybe call the V1 of the Facebook ORM. It was called Ent internally, and Nick Schrock, the guy who kind of co-created GraphQL, was one of the main authors of that. And the way things were done before is basically a bunch of calls to Memcache and MySQL, and you made super duper sure via code review that you were doing everything correctly. And you better hope that the code reviewers knew how to do things correctly as well. And obviously that doesn't scale, especially when you're working in an industry like social media, where privacy is such an important concern. You don't want to accidentally show data to somebody that shouldn't be allowed to see that data. And making sure that those privacy rules are enforced consistently across every single one of those queries to MySQL is really hard to do. And so what this abstraction did for us was it basically provided a single way to fetch your domain data. And what was interesting about it was you weren't just allowed to kind of fetch the data directly. You had to pass in the current user ID as well. And so this data access layer, it wasn't just this thing that was abstracting away MySQL and Memcache. It's like Facebook could expect its engineers to learn SQL and write efficient SQL queries. Really what it was about was abstracting out the business logic and making it reusable. And reusable so that engineers didn't have to reinvent it every time, and that we could be sure that your average kind of engineer coming in off the street doesn't really know a lot about how the code base works, is not going to create a security vulnerability on day one, or a privacy problem on day one. And when you go and kind of look around at a lot of other companies, this was not a Facebook specific thing. Twitter's got something called Strata, which is quite similar. And many other companies I know have built something similar to this. So I just want to pause there. I've been talking a lot, Soren.
Yeah. So one of the things you talked about here, and I think it's very critical to this idea, is that the permission and privacy rules were not in the application layer. It was pushed down into the data layer. And for many developers, if they're familiar with using an ORM or writing raw queries, they kind of mix those two concerns, right? You have to build a new feature. You need to make sure that it does the right thing, but it also has to be secure and not leak any data. You have to think about both things. But what you're saying is that at Facebook, that's not really the case. As an application developer, you're just passing in the token of the user, and you can actually only query the data that that user has access to. So how does that system work, and what does it mean for the developer?
Yeah, that's a great a great comment on that. And so the first thing is that you always have a notion of a viewer or the user that is accessing the data. And again, this is not a Facebook specific thing. We've got a similar thing at Twitter. And the idea is that, at any given point when you are fetching data that might contain personal data, the system knows at a very low level who is actually trying to access that data. And so you can't even get the data without that user being authorized to access that data. And so pushing that concern down as low as you can in the stack means that you can leverage that like across a wider surface area, right? Because like the lower it is in the stack, the easier it is to leverage across multiple domains. And so, that is the one key principle, is to push that down and always have a user ID associated. The second thing, at least with the Facebook one, is immutability. So the idea is that you don't necessarily use the same abstraction for reading and writing. So one of the mistakes I think the Rails ORM made was that models are mutable, right? And like the best practice is to mutate these models all over the place. And, the problem is that I think reads actually look pretty different than writes. And writes often touch like multiple models. And so, it's important to kind of, I think, look at those as maybe different problems. And so the Facebook ORM, the kind of V1 of it that actually created a huge amount of value was it was only on the read path. The write path was still ad hoc, like MySQL query, deleting memcache keys that match a certain regex and stuff, like pretty janky on the write path. But the write paths are generally, more sensitive anyway. And, or I don't know if I'd call them more sensitive, but they're often like subject to much more stringent code review because it's a lot harder to recover from bad write code than it is to recover from bad read code. I think a second principle of that was really valuable was immutability. When you use this ORM to get the data out, not only is it privacy checked, but it's also an immutable snapshot. And so you don't have to worry about it changing over time. And you don't have to kind of shoehorn your writes into the same data model as the reads.
I think this touches on some work I did at my previous job at Trustpilot, where we started as a small startup. We were just using a SQL database, just moving along, getting stuff done. But as we started to grow, we started to realize that we had a scaling issue. And one particular insight we had was that we had 1,000 times more reads than writes. I don't know if that's the same ratio at Facebook, but it's probably something like that. And that means we really needed to optimize the read path, but didn't have to care so much about the write path. So what we ended up doing was having separate collections for writing and reading. And we would have projections from the write side to the read side, optimized for the queries we needed to do.
Yeah. And I know CQRS is a design pattern that became quite popular in the .NET community and then has kind of taken over in a lot of places. And they use a similar playbook. And, previously in between Facebook and Twitter, I was the CEO of a company called Smite, which was Trust and Safety as a Service company. And we actually had the opposite ratio. We had very many more writes than we did reads, but the same design patterns actually still worked great. Yes, the underlying kind of systems below that data access layer, like how do you hydrate this data? How do you do caching? How do you do back pressure on these queues and stuff like that was pretty different, I would say. But when you're actually at the level of an application developer building a user interface or product experience, same tools, same philosophy. It's really interesting how that pattern just works across a wide variety of use cases.
Okay, let's try to shift gear a little bit. I'll ask a few questions related to the infrastructure at Facebook before we move over and talk more about Strata at Twitter. So as an application developer, let's say I'm working on a new feature that requires me to introduce a new field in the data model. How do I do that in this world at Facebook when I don't have direct access to the database?
Well, I think I haven't been at Facebook for a while, so like they're always improving this stuff. But I'll describe it at a high level, how this works at a lot of these places, including how I used to work at Facebook. So I think the first thing you want to do is separate like the physical storage from the logical thing that you're trying to do. So for example, I'm a big believer in shipping like a very like doing things that don't scale, basically. So shipping something that maybe doesn't scale, but you don't need it to scale for that first test where you're testing it 1% of the users, or you're testing some feature that just goes to employees. The logical requirements, the business domain, the entities that you're modeling and all that, like that's usually the same between that early prototype and that kind of final product. But it's the underlying infrastructure that serves up that data and scales with it is what changes. So the first thing that I would say that you want to do is, and I like to start from the design. I like to take a user-focused approach. So I like to have research and design, build a kind of wireframe or a V1 mock, and then we implement that user interface with static fake data. And then we take a look at all right, where do we have to make fake data? And now we know kind of what our domain model is going to look like. We work with our customers, we work with stakeholders, research, we figure out, did we cover everything that we thought we did, making sure that we kind of, do a good job of defining what these interfaces should look like. And then we create a schema for those. And then we back that schema with the appropriate storage medium for the job. So for the majority of stuff at Facebook, it uses a backing store called Tau, which is kind of this MySQL Memcache. Well, it used to be a MySQL Memcache abstraction layer for like expressing graph data. You could think of that also as like another type of ORM actually, but a little more like a graph database. That not every service use that. Some use MySQL directly or other backing stores. At Twitter, this would be backed by a key value store that we have called Manhattan, and other companies have similar stuff. Etsy actually writes some great blog posts about how to scale kind of that stuff. And then you glue that data that kind of underlying physical storage to that domain model. And as you're kind of gluing that's when you're thinking about, okay, what are the access control rules? What type of auditing do we have to do, et cetera? And you do that once, and then every other engineer at the company and any other product can take advantage of that. And so you've taken something that you would normally have to repeat every single time and built it in a reusable way and composable way. I don't know if that answered your question.
No, that's good. And you mentioned picking the right storage medium for the job and kind of decoupling that from the design of the domain model. And that's interesting. And one thing I've discovered in past jobs is that you really need different kinds of storage engines. Sometimes you just need relational data, but sometimes you need to be able to do a full text search, and you want to have more control than whatever relational database you're using can give you. So you need to use multiple different storage mediums, and you need to kind of link it all together. And in a traditional system, the application developer who just wants to build a feature has to deal with all of this, has to sync data across. And I believe that's one thing that these application data platforms at big tech companies are kind of handling for you.
Yeah, that's absolutely right. And these big companies wouldn't be able to deliver any products at all without them, because the risk of introducing some sort of security vulnerability would be so high that like we wouldn't be able to ship anything. You'd have to scrutinize everything so carefully, and you wouldn't have any sort of guarantees. So yeah, it's super, super important from a security perspective as well. But it's a great point too about kind of being able to mix and match your backend stores. And full text search is a great example of that, because I think a really common pattern is you build an application and then there is one product that gets a list of user IDs or post IDs or whatever from a relational database. And then down the line, you realize, oh my God, we have to add search to this product, and search maybe comes a little bit later. And now you've got a search index that returns the same type of IDs. And you don't want to have to like write the same code to hydrate those IDs all over again. So it's like very common that you evolve the indexes, I would say, and the ways that you get those IDs. But you want to keep the way that you hydrate each one consistent.
Now let's explore the application data infrastructure at Twitter a little bit. There's not a lot of public material describing Strata, so perhaps you could just give a quick high-level overview. What is Strata and what does it do?
Yeah, so I'm not on the Strata team. There are a couple of talks that they've given that are pretty interesting, but they tend to talk about the really interesting implementation details, I think. There's a really good talk from Jake Donham from Strangeloop a year or two ago about leverage versus autonomy. It's about kind of the microservice architecture and how Strata tries to get the best of both worlds between microservices and monoliths. And then there was another one from I think it was Mike Solomon at some Scala conference about some implementation details. So I would Google those, check them out. They're really cool. The system is called Stratostore, and we usually shorten it to be called Strato. The main challenge here is, well, let's zoom back and talk about the evolution of Twitter for a second. In the old days, it was a Ruby on Rails application, and it's a Ruby on Rails application that got out of control.
That's where the fail whale came from.
That's where the fail whale came from. And it got out of control because, the Rails ORM wasn't really designed with like caching in mind. And also the programming model of Rails, where you have these like really fat models, engineers were like stepping over each other on each other's toes and stuff. And so then Twitter, back in the early, I want to say like 2010 timeframe, said, okay, we're going to get off Rails and we're going to migrate to this microservices architecture. And so they would look at the monolithic Rails app, which is called the monorail, and they would one step at a time, break something off and turn it into a separate service, and then keep doing that over and over again. And you know what? That worked really well. And it got rid of the fail whale because each of these separate services, people thought really hard about them. They had stable interfaces. They had teams maintaining them. They could use the exact right technology for the job. And then everything was great. But that's not the end of the story, because systems don't stay static. Like, requirements change. You want new product features. You want to ship an experiment that maybe you can't justify spinning up a whole stable team to maintain as their own suite of services. And what ended up happening in that architecture was either products wouldn't ship because they would require so many different changes across all these different services, or they didn't want to spin up their own service and maintain them, or they would spin up their own service, launch the product, and then that service would fall into disrepair, and no one really knew how it worked, and it wasn't maintained super well. So we went from over here in monolith world to way over here in microservice world. Each one had their challenges. And so, I don't know if the Strato folks would call it this, but I would say that kind of Strato tries to get the best of both worlds. You could call it maybe a well-factored monolith or something. But the idea with Strato is they said, listen, we've got all these different microservices with their own different APIs. And the way that an application developer needs to build features pre-Strato is they need to know which service has which data and which APIs to call, and they have to repeat that over and over again. And there was a shared library, but some people used it, other people didn't, and it was a mess. And Strato said, listen, we're just going to create a virtual database. We're going to have this notion of virtual tables and virtual columns, and they could be backed by a real data store, or they could be backed by an underlying microservice. But the important thing is you've got a catalog of all the different data types in one place. And this service knows how to go and talk to the downstreams and aggregate the data back up for you. And oh, by the way, you can add different policies on there around caching, around access control, auditing, that type of thing. And if this probably sounds familiar, right? Because this is exactly what the Facebook ORM did as well, where it's this glue layer between what the engineer is trying to do on the product side and what the infrastructure actually looks like at the bottom. And it glues it together in a way that is reusable and, make sure that the security invariants are maintained.
And crucially, this introduces a layer of separation between the caller of a service and the service underneath. That means you can switch out the implementation at runtime without anybody noticing. And if you are familiar with the modern object-oriented programming, that's a key component. And here you take it to the service level, right, where you can say it is safe for a team to access a database directly, because should that change in the future, you can just inject a service in there that does some transformation live, and the caller won't even know.
Yeah, that's right. And teams do that all the time. We like I think a year or two ago swapped out the storage engine for like a lot of these different services, and all the callers didn't need to know anything about that, which was great.
I spent some time talking to Jake about his work on I believe it's called Strataql, this programming language that can kind of deploy a little function directly into the Strata system. So instead of spinning up a full microservice that you need to manage with its own clusters and so on, you can just write a little bit of code that you inject into the Strata infrastructure. How does that work?
Yeah, that's a great question. And it's frankly, it's an area where I have some disagreements with probably Jake or whoever came up with it. But so the idea here is that you've got this database, this virtual database, right? And your whole domain model is modeled basically as like tables and columns. And it's a super flexible data model. It can model anything. We've known that since the 70s or whatever, when we started working. I think it was actually even before that when we really developed the relational model. And so the next kind of logical question is like, how do we query this thing? Do we just use an API? Do we introduce something like SQL? Like, do we need a query language? And as developers would use this, they would realize like, yeah, this is great that we have all this data in one place. But we still need to write these little nuggets of functionality that glue some data together. So a good example is like, I want to go fetch the IDs from this column. And now I have a list of post IDs. And then I want to go hydrate each post, right? And so that's like fetch from this one column, and then for each post, go fetch from this other column. And you shouldn't have to spin up a separate service for that. And like that logic needs to live somewhere, basically. And so what was really innovative and interesting about Strataql was the thinking was, let's embed that logic directly in Strata. So it can be an application development platform. So you write your Strataql query that does that kind of glue code stuff. You upload it to Strata and it runs on Strata, and then you don't have to think about it anymore. If you go and check out a lot of those talks that I mentioned earlier, they will talk in detail about how Strataql works. It's really interesting stuff around like automatic, parallelization of data fetching and things like that. It's really, really interesting and unique approach to that problem. Frankly, where I would disagree with the team though is like, it is a new language to learn. And the question is like, do we need more languages in the world? I say this is someone who's made a couple of them. And the counterpoint to that is that Strataql is designed with semantics to make it easy to run without knowing what the code does. And it's like thousands of engineers can put whatever crappy Strataql code they want, and it won't take down the service. So like that's the motivation for it. And like I think it's an interesting discussion to talk about. Like, hey, like what does that trade-off look like? But yeah, it's a really interesting system.
When you go to any organization of a certain scale and look at the data infrastructure, you'll find some Kafka, and you'll find big stream processing frameworks that essentially just take data from here, transform it in some way, and like maintain a projection over here. It's a lot of machinery for relatively simple projects. Does infrastructure like Strata help you avoid all of that complexity?
Yeah, that is actually something that team has evolved. So it started out as this abstraction over this suite of microservices, and now you can actually build Kafka consumers directly in Strato for those types of use cases where you're like tailing a Kafka topic. You want to do some sort of basic transformation or like call a service or like join it against data in some service. And so there's something called Strata streaming that supports that. But yeah, I mean, in my view, most companies should not be in the business of doing anything related to distributed systems. They shouldn't even have to think about it. Even though everything is a distributed system, it's like there's been so much research and there's so many good abstractions and best practices that we have that your average engineer should just have to think about the data transformation and like modeling the state. And then like for 80% of use cases or maybe beyond that, they shouldn't have to worry at all about things like caching or like service mesh or what the retry policy is on their Kafka consumer. Like this is all stuff that like people love to like talk about and blog about and go to conferences about, but like as somebody just trying to get stuff done at their job, like you shouldn't have to worry about that.
I fundamentally agree with that. And I think the popularity of things like serverless functions, Lambda, show that a lot of developers really just want to deploy some feature code that can get the job done and then move on with it. I think what we are seeing is that databases are not really keeping up with the demands of growing applications. And that's why there's this emerging layer of a component in front of the data stores that help application developers get the level of abstraction they need to build their features without having to dive down into that distributed systems theory stuff that they shouldn't really have to care about.
Yeah, I partially agree with you on that, but I would like to add that there are different layers of abstraction. Like I think that the right way to think about application development is that the logical domain of your application is like totally different thing than the physical storage and the way that you store the data physically. And, maybe there's some applications that overlaps 100%, like in your hello world MySQL application, like that's going to overlap 100%, but you should architect your system with those two things like completely independent. So your application developers don't need to worry about like data migrations on the server side or on the like come deep in the infrastructure somewhere, or you don't like marry a cloud provider or something, like some companies don't want to do that. So I think it's important that it's not only that the distributed systems problems are hard, it's also like, to me, like two different problem spaces entirely.
That makes sense. Pete, this has been great. I want to start winding down a little bit and have just a couple of final questions. I think many people in the audience today are in companies where they are using an ORM, writing raw SQL, or being in this world that I think most application developers are in. And now maybe they're curious. They're thinking, should we try to raise the level of abstractions for our team, for ourselves? When is the right time to start thinking about that and how to even approach that? Do you have thoughts on that?
Yeah, I think you're talking about a refactor, and when do you refactor and how far do you go with that refactoring? My recommendation is, I mean, it's so different depending on the space that you're in and the problems that you're solving and like what your management chain cares about and what your incentives are as an individual engineer and stuff. But like broadly, these refactors don't have to be that expensive. Like they can be as simple as like a wrapper function around what you're already doing and just renaming it in a way that like starts to future-proof this. So, if you've got some place where, you're calling this SQL query directly, just put a function in front of it, copy paste the code in, and then tell everybody, hey, like this is the new way to do it. Call this function instead of copying and pasting this code, and then do that over and over and over again until you've got some subset of your code copied and pasted into this new set of functions. And now what you've done is created this abstraction that you could then swap out the underlying infrastructure, or at least now you can search for all calls to that function, and every place where you're fetching that data. So that's a pretty simple refactoring. I've heard people call it the concentrator pattern before, where you just have functions that don't really do much, but like they concentrate, like they're like a funnel in which all the same concerns go through. And then also, I would tie it to what the business cares about. I mean, at the end of the day, I think that your engineering organization is either going to be biased too much towards velocity, or it's going to be biased too much towards quality. So you're either moving really fast and introducing tons of bugs and security flaws, or you're moving super slow, missing the market, but you're not introducing security vulnerabilities and stuff. And so I think that these abstractions can solve either one of those problems. But framing up that work in a way that matches what the organization has identified as a challenge, I think is important. And so if you keep hearing from, your management chain, hey, like, let's get these features out faster, say, hey, listen, like we need to take some time, refactor the code so we can get more leverage on what we've already done. Or if you're hearing, oh my God, like we had the security incident, or like we're really worried about bugs. Again, it's like, hey, we got to slow down, refactor so we can reuse the code, get it really tested and solid, so we don't have to, so we have a smaller surface area for bugs and security vulnerabilities.
This idea about writing your code in a way where it is ready to be refactored in the future when you need to go to that next level of infrastructure makes a lot of sense. And in fact, one of the key philosophies of Prisma Client is that it has to be future-proof. So we have designed the client in such a way that, yes, it's really nice to use. It gives you auto-completion. It's amazing. But more importantly, we have learned from engineers at Facebook and Twitter and other tech companies, and we are designing this application data platform to provide some of these benefits. And if you're using Prisma Client today, you'll be able to just point it at this new thing and start using that without having to change all of the application code.
Yeah, that's absolutely right.
One softball question. Have you ever worked at a place outside Twitter or Facebook where you would wish you would have had their infrastructure?
Well, I started my own company, and we were going for like 3.5 years, and we sold it to Twitter, and we were basically building a B2B. You can think of it as kind of like a B2B data analytics type of product, where we were trying to identify spam and abuse, but at the end of the day, it's like ingesting a bunch of events, computing a bunch of features and rules and ML models on it, and then like visualizing it for customers. And what we found was like every customer wanted to visualize something a little bit different. And I was like, I wish we had GraphQL. This was like, we actually started the company before like the open source release of some of the GraphQL stuff. And so we built like a crappy version of GraphQL to power a lot of our dashboards. And we had to do that as an independent company. And so, yeah, I mean, everywhere I go, and every company that I talk to has built some version of this or needs some version of this. And, I'm in like these ex-Facebook forums and groups of stuff, and people are like, where's Tao? Like, where's Ent? Where's the open source version of this stuff? And like, actually a lot of people chime in and say, hey, like, go look at Prisma. But, it's certainly a problem that every company has, I think.
Peter, this has been great. Thank you so much for joining us today. And I look forward to chat more to you in the future.
Yeah, thanks so much.